This video will cover beginner questions regarding the topic of integrating logarithmic functions. The definition of the absolute value is if x is greater than or equal to 0, then x. If x is less than 0, then minus x. In here, x cannot be 0. If x is greater than 0, that means absolute value of x equals x. d dx of ln absolute value of x is d dx of ln x. The answer is 1 over x. If x is less than 0, that means absolute value of x equals minus x. d dx of ln absolute value of x equals d dx of ln minus x. Use the chain rule, 1 over minus x times minus x prime, 1 over minus x times minus 1. The answer is 1 over x. So we have the same answer. Then d dx of ln absolute value of x equals 1 over x. X cannot be 0. Now we have a formula. The integral of 1 over x dx is at an absolute value of x plus c. Now let's use this formula to integrate natural logarithmic functions. Number 1, we can rewrite as 3. The integral of 1 over x dx equals 3. Using the log rule for integration, ln absolute value of x plus c. Number 2, use U-substitution. Let u equal x minus 4, then du equals dx. Now change all x with u. The integral of 1 over x minus 4 is u. dx is du. Equals ln absolute value of u plus c equals ln u was x minus 4 plus c. What we are going to organize here is that the coefficient of the denominator is 1 during integration. There is no need to use u substitution, just think of it as x. How about this? Move the constant to here, then integral of 1 over x plus 5 dx equals 4 ln absolute value of x plus 5 plus c. Now we have a formula. Please remember this. Number 4, use u substitution. Let u equal 2x plus 3. Then derive on each side. du equals 2 dx. There is only dx. Then divide by 2 on each side. du over 2 equals cancelled dx. Now replace all x with u. The integral of 1 over 2x plus 3 is u. dx equals du over 2. We can rewrite as 1 over 2. The integral of 1 over u du equals 1 over 2 at an absolute value of u plus c equals 1 over 2 ln absolute value of u was 2x plus 3 plus c. Let u equal ax plus b. Derive on each side. du equals a dx. There is only dx. Then divide by a on each side. du over a equals cancelled dx. Let's change all x into u. The integral of 1 over ax plus b equals u. dx equals du over a. We can rewrite as 1 over a the integral of 1 over u du equals 1 over a, and an absolute value of u plus c equals 1 over a, and an absolute value of u was ax plus b plus c. If the denominator of the rational expression is a linear expression, simply integrate with ln. After that, you can write 1 over the coefficient of x, which is the derivative of the linear expression. Use this formula. Just write down at an absolute value of 4x minus 3 plus c, then 1 over 4, which is the coefficient of x. Also, when you derive 4x minus 3, the answer is 4. Number 7, use this formula. We can rewrite as 5, the integral of 1 over 7 minus 2x dx equals 5, then ln absolute value of 7 minus 2x plus c, then times 1 over minus 2, which is the coefficient of x. Then we can rewrite as minus 5 over 2 times ln 7 minus 2x plus c. Number 8, to integrate tangent x, convert tangent x to sine x over cosine x dx using the trigonometric identity. Now use U-substitution. Let u equal cosine x, then du equals minus sine x dx. There is only sine x dx, then divide by minus 1 on each side, minus du equals cancelled sine x dx. Now change all x into u. The integral of sine x dx is minus du over cosine x is u. We can rewrite as minus integral of 1 over u du, then minus ln absolute value of u plus c, minus ln u was cosine x plus c. When writing the substitution law here, some students ask, can we use sine x as u? Differentiating sine x gives cosine x. But look closely, we see cosine x, but it's actually 1 over cosine x, which is secant x. So we should put u as cosine x. Now use the logarithmic identity. We can rewrite as ln absolute value of cosine x over here to the power of minus 1 plus c. Then we can rewrite as 1 over cosine x plus c equals ln secant x plus c. Now we have a formula. Number 9, using the trigonometric identity, we can rewrite as cosine x over sine x dx. Now use u substitution. Let u equal sine x, du equals cosine x dx. Let's change all x into u. Cosine x dx is du over sine x is u. We can rewrite as in the integral of 1 over u du equals at an absolute value of u plus c equals at an absolute value of u was sine x plus c. In here, sine x equals, we can rewrite as sine x to the power of 1 equals sine x to the power of 1 equals minus 1 times minus 1, then minus 1 to the power of minus 1. equals 1 over sine x to the power of -1, then cosecant x to the power of -1. Then back to the original, ln absolute value of cosecant x to the power of -1 plus c. -1 can go down, minus ln absolute value of cosecant x plus c. Now we have a formula. Please remember this. Number 10, let u equal to plus cosine x du equals minus sine x dx. There is only sine x dx, then divide by -1 on each side, minus du equals sine x dx. Now replace all x with u, the integral of 5 over here, then sine x dx is minus du over 2 plus cosine x is u. We can rewrite as minus 5, the integral of 1 over u du, equals minus 5, and an absolute value of u plus c equals minus 5, and an absolute value of u was 2 plus cosine x plus c. In here, the range of cosine of x is -1 to 1, then plus 2 on each side, 1, cosine x plus 2 is less than or equal to 3. So cosine x plus 2 is always positive. Now we can rewrite as minus 5 ln bracket 2 plus cosine x close the bracket plus c, not the absolute value sign. Let u equal tangent x du equals secant square x dx equals the integral of secant squared x dx is du over tangent x is u. Then ln absolute value of u plus c equals ln absolute value of u was tangent x plus c. Let u equal e to the power of x plus 2, then du equals e to the power of x dx. Let's change all x into u. The integral of e to the power of x dx equals du over e to the power of x plus 2 equals u. Ln absolute value of u plus c equals ln absolute value of u was e to the power of x plus 2 plus c. We are not done yet. In here, e to the power of x is always greater than 0. So e to the power of x plus 2 is also always positive. Then you can change the bracket, e to the power of x plus 2, close the bracket, plus c, not absolute value sign. Let u equal ln x, then du equals 1 over x dx. Now replace all x with u. The integral of cosine ln x equals u, then 1 over x dx is du. Then antiderivative of cosine u is sine u plus c equals sine u is ln x plus c. Let u equal x cubed minus 3x squared plus 6x, then du equals 3x squared minus 6x plus 6 dx. Then du equals, take out the common factor, which is 3, x squared minus 2x plus 2 dx. There is only x squared minus 2x plus 2 dx. Then divide by 3 on each side. Du over 3 equals, cancelled, x squared minus 2x plus 2 dx. Now replace all x with u. The integral of this part is du over 3. 1 over this part is u. We can rewrite as 1 over 3. The integral of 1 over u du equals 1 over 3 ln absolute value of u plus c equals 1 over 3 and an absolute value of u was this, x cubed minus 3x squared plus 6x plus c. This is the last one. If you can't memorize the formula, you can expand it one by one. So x plus 1 over x times x plus 1 over x times x plus 1 over x equals x squared 1 plus 1 plus 1 over x squared times x plus 1 over x equals, we can rewrite as x squared plus 2 plus 1 over x squared times x plus 1 over x equals x cubed plus 2x plus 1 over x plus x plus 2 over x plus 1 over x cubed. We can simplify x cubed plus 2x plus x is 3x plus 1 over x plus 2 over x is 3 over x plus 1 over x cubed. Or it is convenient to use the binomial theorem by memorizing it. A plus b cubed equals a cubed plus 3a squared b plus 3ab squared plus b cubed. So x plus 1 over x cubed equals, x is a part, 1 over x is b part. X cubed plus 3 times x squared times 1 over x plus 3 times x times 1 over x squared plus 1 over x cubed equals x cubed plus 3, x is cancelled, x plus 3, x times this one is 1 over x squared plus 1 over x cubed equals x cubed plus 3x plus 3, x is cancelled, over x plus 1 over x cubed. We have the same answer. So we can rewrite as x cubed plus 3x plus 3 over x plus, make the power form, x to the power of minus 3 dx equals, use the power for integration, x to the power of 4 over 4 plus 3 times x squared over 2 plus 3 times ln absolute value of x. The integral of x to the power of n dx equals x to the power of n plus 1 over n plus 1 plus c. Then this one x to the power of minus 3 plus 1 over minus 3 plus 1 plus c equals x to the power of 4 over 4 plus 3x squared over 2 plus 3 ln absolute value of x plus x to the power of minus 2 over minus 2 plus c. Then the final answer is x to the power of 4 over 4 plus 3x squared over 2 plus 3 ln absolute value of x minus 1 over 2x squared plus c. I hope this video has been helpful. If you have any questions, leave them in the comment below. Thank you for watching. Please like and subscribe for more.